Okay, guys, so in this lecture, we are going to talk about another blood condition called polycythemia, and it has two major types. Okay, by definition, okay, we'll come to polycythemia in a bit. There's something else that I want to do before polycythemia, and this was something that I didn't cover in the previous lecture, so let's do this first. Okay, we did the last lecture was on anemia and its types. Okay, anemia was a blood disorder in which the hemoglobin concentration decreases below the original value. So now below the normal value, and now we are going to look at a few effects on of anemia on the circulatory system. Okay, viscosity. First effect is the viscosity of the blood. Viscosity is the resistance to flow of a fluid or resistance to flow of a liquid. So viscosity of a blood is how easily the blood can flow. It largely depends upon the number of red blood cells which are present in the blood. So if in anemia the number of red blood cells decreases, so the viscosity, which has a normal value of 3 times the viscosity of water, it decreases as well to 1.5 times. So this means that viscosity becomes half of its original viscosity due to anemia, because the number of red blood cells has decreased. So the blood can more easily flow through the blood vessels, and actually easier flow have more disadvantages rather than advantages. Well, the disadvantage is that the blood will flow more quickly, and so the tissue and won't give the tissues enough time to get oxygenated. Okay, let's discuss. Blood would flow more quickly through the tissues and return faster to the heart, and therefore the cardiac output from the heart will also increase. Okay, and so this will actually increase the workload on the heart. Hypoxia resulting from diminished transport of oxygen by the blood in the peripheral tissues causes the blood vessels to dilate, the peripheral blood vessels to dilate, allowing more blood to flow through the tissues, hence increasing the cardiac output even more and increasing the workload on the heart even more. So basically, the viscosity decreases, and since it's anemia, so the hemoglobin concentration is less in the tissues. So the peripheral blood vessels, they dilate because they are not actually supplying enough oxygen to the peripheral tissues, and so this dilation also increases the amount of blood which is returning back to the heart, and hence increases the cardiac output and therefore increases the pressure on the heart, the workload on the heart. So that's one of the reasons why it can drive towards cardiac failure as well. We'll talk about that. Increased supply of blood might be able to fulfill this oxygen demand, because now, since the there is diminished supply of oxygen to the peripheral tissues, so what the blood vessels do is that they dilate themselves and allow more volume of blood to be transported to the peripheral tissues. This will actually neutralize the effect of low oxygen concentration to the peripheral tissues, because now more volume of blood will be supplied to the peripheral tissues. So they uh, might be fulfilling the oxygen demand, but this will still have a higher workload on the heart, and so again this increases the probabilities of cardiac failure. Okay, now anemic people who do exercise, okay, who exercise, what would happen to them? Well, the demand of oxygen by the tissues increases when a person exercises. Obviously more ATP is required and more respiration occurs, so the by the tissues increases to an even greater extent. So the heart, okay, this heart now is required to pump even harder to fulfill this oxygen demand. And since you guys know that heart is already under a great pressure of pumping a high amount of blood, so this heart cannot no more pump blood as effectively than it already is. So acute cardiac failure might occur. Okay, cardiac failure might occur, a short term, a quick cardiac failure might occur. It might occur immediately. Okay, so these are a few effects of anemia on the circulatory system. So basically, the major effect is that it actually decreases the viscosity, due to which the cardiac output increases because of the dilation of the blood vessels, and uh, increase rate of return of blood to the heart, and this increases the cardiac output and increases the workload on the heart and eventually can lead to acute cardiac failure. Okay, so these are the actual effects of anemia on the circulatory system, and that's because the red blood cells concentration has decreased, and viscosity depends on the number of red blood cells which are present in the blood. Okay, now let's look at our today this lecture's main topic, the polycythemia. Okay, polycythemia is actually reverse of anemia. In anemia, since the hemoglobin, we know that the hemoglobin concentration decreases in the blood. Over here, it is a condition of elevated hematocrit. Hematocrit is basically the percentage volume of RBCs in the blood. I've talked about this in the previous lectures as well, that it is actually the volume of red blood cells divided by the total volume of the blood times 100. Total volume of the blood times 100. This is your hematocrit. Okay, this is hematocrit. So it is actually the percentage volume of red blood cells in the blood. Okay, there are two types of polycythemia. Now, the major effect is that it increases the hematocrit levels. Okay, now in both of these polycythemias, the hematocrit level will increase, but in one it will increase to a lower extent as compared to the other. One of them is mostly physiological while the other is mostly pathological. Okay, the first type is secondary polycythemia. Secondary polycythemia is actually a defense mechanism, or I should rather say it is a way in which the body adjusts its environment to get the maximum oxygen when the tissues become hypoxic, when the tissues when the oxygen tension in the tissues decreases due to too little oxygen being breathed in. Okay, this can be one reason why the tissues might get hypoxic, because and for example, at high altitude, since we know that the oxygen partial pressure in the air is much lower than as compared to the sea level, so what would happen is that the oxygen that enters a person's lungs would be much lesser, and due to this the oxygen that enters the blood will also be lesser. During cardiac failure can be another reason why the oxygen tissues might become hypoxic. The RBC production increases in the blood in response to this hypoxia, and we've talked about the mechanism by which it occurs in the previous lectures. I've given the link of that lecture down in the description. Do check that out if you want to learn the mechanism by which hypoxia increases the red blood cell production. It's basically due to the increase in erythropoietin concentration that causes the hematopoietic stem cells to increase the RBC production. Okay, then anyways, this is red blood cell production increases until the hypoxia is relieved. Okay, so secondary polycythemia, and this is these values are quite important. I guess guys should learn them. RBC count, it increases to 6 to 7 million per cubic millimeter, okay, of blood. Rather, the normal count is average normal count is around 5 million. Okay, so almost like a million RBCs have increased per cubic millimeter of blood, about 30% above the normal level. Okay, above about 30% greater than the normal level of the total blood. Okay, so this is how the RBC count increases. Physiological polycythemia that occurs in natives. Okay, natives are basically living in the high altitudes. Okay, there is another type of polycythemia called the physiological polycythemia, which mainly occurs in the natives who are living in the high altitudes. As I told you guys that at high altitudes, the partial pressure of oxygen is much lesser in the environment. So the oxygen that enters the person's blood is much lesser than it is required by the body. So what happens is that physiological polycythemia occurs by in which the red blood cell count in the body increases so as to tackle this oxygen demand to so as to fulfill the oxygen demand needed by the body tissues. Okay, 6 to 7 million per cubic millimeter of the blood. This is the value through which the RBC count increases. Okay, from 5 million to 6 to 7 million. So this polycythemia is this is the physiological type of polycythemia, which usually occurs in natives that are living in the higher altitude environments, and it mainly occurs in response to in response to oxygen hypoxia of the tissues. Okay, so as to supply the demand of oxygen, the increased demand of oxygen to the tissues. Now let's talk about the pathological type of polycythemia, which is known as polycythemia vera. Okay, guys, so Polycythemia vera, which is also known as erythemia. Polycythemia vera is a pathological condition in which the red blood cell count increases to approximately 7 to 8 million rather than the average 5 million per cubic millimeter, and the leukocytes and platelets, the other blood components, also increase above their normal value. The hematocrit level also increases to approximately 60 to 70% rather than normal 40 to 45%. Okay, so this is not like the secondary polycythemia, but rather this is more extreme polycythemia. The red blood cell count also is much greater as compared to the secondary polycythemia, and the hematocrit level is also much greater than the secondary polycythemia. Okay, it's much greater than the secondary polycythemia. Okay, and so in this case, this is basically a genetic abnormality. This is not a body's physiological control mechanism. This is rather pathological genetic uh, mutation, genetic aberration that occurs in the hemocytoblastic cells. Hemocytoblastic cells are basically the stem cells that are responsible for the production of all the different types of blood cells. These can be thought of as the pluripotential hematopoietic stem cells, and they give rise to leukocytes, red blood cells, etc. Okay, the blood components. So if genetic aberration occurs in those cells, then it's likely that the polycythemia vera might develop, in which all these conditions might be present. Then total blood volume also doubles. Okay, it also increases along with the hematocrit level. Okay, and the viscosity, as I told you earlier, that viscosity depends upon the number of red blood cells present in the blood. So since the number of red blood cells have increased to a very large value, so the viscosity also rises to very large value. Okay, it also increases to approximately 10 times the normal value, 10 times the normal value rather than the average 3 times of viscosity of water. Okay, so it increases to approximately 10 times more. Now, uh, okay, if you this is a diagram that I've given for polycythemia vera, in which the normal red blood cell count has increased tremendously, and it can be thought of as a blood cancer as well. Although it is not blood cancer yet, it can lead to blood cancer. But in blood cancer as well, you can see that the bone marrow produce too many red blood cells and leukocytes. Okay, so this was it for polycythemia, the two types of polycythemia that we needed to do. Now we'll have to look at the effects of polycythemia on the circulatory system, just like the effects of anemia on circulatory system. Okay, but rather the effects of polycythemia on circulatory system are the reverse. Most of them are reverse of anemia. Okay, so let's begin. Okay, increase in the hematocrit level increases the venous return to the heart, but the cardiac output is not much far from the normal due to the sluggish flow of the highly viscous blood. Okay, since the blood has become very viscous, it will flow very slowly. So although the hematocrit has increased, although the red blood cell count has increased, but the cardiac output remains almost near the normal value, because the increased hematocrit approaches the heart very slowly. It enters the heart very slowly, so the cardiac output remains almost near the normal value. Okay, then let's look at the arterial blood pressure. Well, in most cases, it remains normal. Okay, it remains close to normal because because the body's blood pressure regulation mechanism is strong enough to counter this change, and it is efficient enough to prevent the blood pressure from rising. But in about one third of the cases, the elevated blood pressures are also seen. So this shows that most of the blood pressure regulating mechanisms are efficient enough for maintenance of the blood pressure. Okay. Now, what's the third effect of polycythemia? Okay, the first two effects were the increase in hematocrit, increasing the venous return to the heart was the first effect, but keeping the cardiac output constant, or cardiac output close to the normal, the first effect. And the second effect was that the increasing the arterial pressure in some cases, but keeping it almost near the normal value in most cases. Now let's look at the effect of polycythemia on the skin color. Well, the skin color is also affected by the amount of blood that flows in the subpapillary venous plexus. Subpapillary venous plexus is basically the the collection of veins just beneath the skin. Okay, as we know that skin is as we know that veins are superficial and arteries are deep seated. So in these superficial veins, as the blood flows, the complexion of the skin is also affected by the color of the blood that flows through this venous system. Okay, now as this is polycythemia, and as this is an increase in the red blood cell count. So the blood which passes through the subpapillary venous plexus, it will be richer in red blood cell. In case of polycythemia, the venous return through the subpapillary plexus increases since it passes slowly. But as we've talked about it earlier, that since the blood is very viscous, so it will flow very slowly. So if it flows slowly, this would mean that the oxygen which it carries, it will get used up by the tissues, the surrounding tissues, very easily and very quickly. Okay, this would mean that the highly deoxygenated, the blood would become deoxygenated in a very short time, and so most of the deoxygenated blood will flow through the skin, skin subpapillary plexus. Okay, it gets deoxygenated because more hemoglobin gets deoxygenated, and hence the skin of the person may appear to have a reddish complexion with a bluish shade. Okay, it might be red due to high amount of red blood cells, but like they'll be the bluish complexion will also be observed due to the high deoxygenation of the blood. Okay, so that's it for polycythemia. Thank you so much. I'll be giving the link for the next video in the description as well. Uh, Thank you so much.